Metrics can tell you a pod is busy or restarting. Logs help you see what the application actually said before, during, or after the problem. Kubernetes expects containerized applications to write useful output to standard output and standard error. The container runtime captures those streams for the kubelet. When you run kubectl logs, you are not SSHIN into the node. You ask Kubernetes for the pod log subresource, and the kubelet returns the container log content. The basic command is intentionally small. For a pod with one container, kubectl logs followed by the pod name returns a snapshot of its current logs. Kubectl logs is not limited to a raw pod name. You can ask for logs from a workload resource, such as deployment/nginx or job/hello, when that is the object you are debugging. If the pod has multiple containers, name the container. Use -c for one container, or all containers when you intentionally want every stream together. When logs come from multiple pods or containers, add prefix. It keeps the source pod and container attached to each line, which matters when replicas behave differently. For CrashLoop backoff, the current container may not live long enough to inspect. Use previous logs to read the last terminated container instance. If the pod is still starting, kubectl logs can wait for it. The pod running timeout option controls how long kubectl waits before giving up. Do not dump endless logs when you need a tight answer. Follow live output, tail recent lines, limit by time, and include timestamps when timing matters. For very noisy pods, bound the output. You can limit bytes, use a relative sense value, or start from an exact RFC 3339 timestamp with sense time. When a deployment has many replicas, one pod may not tell the whole story. Use a label selector to pull logs from the matching workload pods. A selector can fan out to many pods. When following or reading many matching pods, max log requests limits how many log streams kubectl opens at once. When you ask logs from a resource, all pods can expand the request across the pods owned by that resource. Combine it with prefix so each line keeps its source. A clean debug loop separates signals. Describe and events explain Kubernetes lifecycle decisions. Logs explain what the application process printed. A key rotation detail, kubectl logs, returns the available container log content. If kubelet rotates a large log, only the latest log file is available through kubectl logs. Not every useful log is an application log. On Linux nodes using systemd, kubelet, and container runtime logs are commonly inspected with journal_ctl. On Linux, kubelet directs the container runtime to write pod logs under directories such as /var/log/pods. Changing that default path needs caution. Kubectl logs is not long-term storage. Kubelet rotates container logs and only available log files are returned. For history, you need cluster-level logging. Kubelet manages container log rotation. The main settings are container log max size and container log max files, with defaults commonly around 10 megabytes and 5 files. For production history, logs usually leave the node. A daemon set logging agent can collect standard output and standard error streams and forward them to a backend. The common cluster logging pattern is a node-level agent. Run it as a daemon set so every node has one collector that reads local pod logs and forwards them. If an app writes separate log files, a streaming sidecar can tail each file and write it to its own standard output stream. Then kubectl logs can target each sidecar container. Sidecar logging is useful, but it has overhead. If the application can write directly to standard output and standard error, that is usually simpler and avoids duplicating log storage on the node. The mental model, applications print logs, the runtime and kube let preserve what is available, kubectl reads it, and a logging backend keeps the history.